So hello, good day. So today we want to look at trigonometric equations. Okay. The three ratios that we have the um, tan theta, cos theta, sin theta, right? And these equations we have different curves for it. So we could have tan theta is equals to a, for instance. Now this is an equation. How do we find the solution to this equation? We say our theta is equal to arctan of A, right? Arctan of A. That is how we get our theta. You know that this theta that we see here could have different values as well, other than this one, this particular value. This value is usually between 0 and 90 degrees. But there are other values that we also need to get. Because if you look at tan theta, if you look at the curve, for instance, let's say this is the curve, line of asymptotes, line of asymptotes. Let's say another curve is here. Then line of asymptote is here. Then let's say another curve is here too. Line of asymptote is here. Okay. Let's say it starts from the origin. Y is equals to, let's say this one is theta. Or let's call this one x, for instance. X. And that is this A. You see, this A is a straight line that passes through. It's a straight line that passes through the curve of tan theta all through. And when it passes through that curve, it's cut it at a specific points. Specific points. Like this one, it's cut it here. The line of asymptote is here. That line that's, when you extend this to infinity, they all meet at infinity there. Then it's cut it at this point. You see all these points here? That's the value. The value of theta is this point. That is the first or the smallest angle that we get here. The other values of theta, they are obtained at these points, right? And if you look at here, this is theta. Now this is 90 degree. This is 90. This is 180, right? So this particular point here is 180 plus theta. If you draw another point, another curve here, right, and you put it there, if you extend this, it's going to cause this curve at this point. This is 180 now. This is 270, and 180 plus theta. Okay, this is 270. This is 360, right? This point here is going to be 360 plus theta, and that is how it will continue to go. So we have seen a pattern, and that pattern is that the actual x, which is going to be theta plus n 180. So this is the actual solution. So which means n is now is to be 0, 1, 2, 3, and up to infinity, like that. So which means this is 180. That is 180. This is 2 times 180, which is 360. The next one you will see is going to be, add another 180 to it. You get it now? So it will continue like that. So that is the number of 180. So it continues in multiples of 180. But the theta will always be added plus theta, add plus theta, add plus theta. You get it? And the same thing for the one on the negative side of the curve. So n could also be -1, -2, -3, and it could also go on like that. So this is the general solution for this situation, right? So once we get our theta, which is the one we got from here, so if we want to get the other values of theta, Then you apply this formula, which is S is equals to theta plus n 180, where n will now be specified. So in some question, they can ask you, they can specify the range. They say if you can say between 0 degree and 360 degree. So if they specify the range, it means you have to find your theta between these two angles, right? And if they say between 0 and 360, which means you are going to restrict yourself, your answers to this region. Yeah, whatever values you don't get. So which means if you first of all get your theta from here, then to get the second theta, just add 180 to it to the theta. And that's when you get your second value. You get it? So that is how you go about this, right? So this is how to get the value for theta, Yeah. Okay, thank you.